All right, today we're going to take a look at writing the rules for arithmetic and geometric sequences using a formula. So the first term we're going to go over is arithmetic. That's a sequence that can be expressed as a sub n, meaning finding the nth term equals a sub 1, so our first term, plus, open parentheses, n minus 1 close parentheses times d. Now d is just going to remain in the formula. We won't be substituting a value in for that unless we're evaluating the rule that we write. And d is our common difference. And our common difference is found by taking a sub n plus 1 minus a sub n. Pretty much what's that saying? You're taking like term 2 minus term 1, or your third term minus your second term, your third term minus your second term, fourth term minus the third term, fifth term minus the fourth term, and so on there. And one thing we'll talk about is our difference for an arithmetic sequence is always constant. So the difference between your sequential terms is going to be the exact same. All right, so that's arithmetic. Now the next term we're going to take a look at is geometric. Geometric sequences, we can use a formula to write the rule for those as well. Keep in mind you can also just find these algebraically by some guess and check, but we can also use this formula, which is a sub n equals a sub 1, our first term, times r raised to the power of n minus 1. Now in this case, once again, n we'll be leaving this in, that's going to be the variable in our equation. R for this one is our common ratio. And our common ratio is a sub n plus 1 over a sub n. Another way to take a look at that as your second term over your first term, third term over your second term, fourth term over your third term, and sequential terms like that. Now for geometric sequences, our ratio is going to be constant, meaning your first or second over first, third over second, fourth over third, and so on. We're going to have the same constant ratio. And I'll also be showing y'all another way we can represent that as well. All right, so for today we're going to be taking a look at the question. We're going to tell if a given sequence is arithmetic or geometric, and then we're going to write a rule for it. Now, when we write the rule, we'll be using either the geometric sequence formula or the arithmetic sequence formula. But once again, you can also do these by hand, and some are easier to others to do by hand and just guess and check, but some it's nice to have that given formula, so you can just plug in those values and move on from there. So the first sequence we have is 2, 11, 20, 29, and 28. I am going to show y'all a neat trick of how to tell if it's arithmetic or geometric. Now what you do, you first want to find the commonality between the two terms. So to get 9 to 11, I'll add 9. To get 11 to 20, I'll add 9. To get 20 to 29, I'll add 9. To get 29 to 38, I will also add 9. Now, this one we only needed to go one layer deep, and we get that same number. If it's the same on the first line, this is a common difference. If it's not the same, you'll want to move on. So since we have a common difference here, we have an arithmetic sequence. And since we have an arithmetic sequence, we have a common denominator, or a d value, and that d value is our second term minus our first term, or any sequential term minus the term before it. So our common difference here is positive 9, since 11 minus 2 is 9. Now for our formula, we need to know what a sub 1 is, meaning our first term. So to find the first term, we look at our sequence, and the first term given is 2. So a sub 1 equals 2. So now we have all the information we need to write the rule, which we'll use a sub n equals a sub 1 plus, open parentheses, n minus 1 times d. So our rule here, a sub n equals a sub 1, which is 2, plus, open parentheses, n minus 1, it's always n minus 1, times our d value, which is 9, which is our common difference. All right, from here we do want to distribute the 9 to n and negative 1, and then combine like terms and write this in a more sort of visually appealing manner. So this will equal 2 plus 9n minus 1, or 9n minus 9, excuse me. Combine our like terms of 2 and negative 9. So our rule, a sub n equals 9n minus 7. Now you do want to get in the habit of writing your term within first, and so writing those in standard form. So when we have a variable, that will come before a constant or that number. All right, our next problem we're going to take a look. All right, so we're taking a look at the next sequence, 4, 8, 16, 32, 64. Now we can tell off the bat here, if we went that layer deep, to get 4 to 8 we add 4, 8 to 16 we add 8, 16 to 32 we add 16. So we don't have a common difference there. So we're going to try to take a look at our common ratio. So our common ratio, we'll do 8 over 4, 16 over 8, 32 over 16, 64 over 32. Keep in mind, whichever term you take a look at, you compare it or you put it over the term right before it. So here all our common ratios, or all our ratios, excuse me, are 2. So that common ratio is going to be our R value. So since we have a common ratio that's constant, we have a geometric sequence. All right, now our ratio for all of these is 2. So that's going to be our R value. Now once again, for the geometric sequence, we also need our first term. And our first term is 4. So we have everything we need to move on to plugging it into the formula for the rule. A sub n equals A sub 1 times R raised to the power of n minus 1. All right, so A sub n here equals A sub 1, which is 4, then times R, which is 2, raised to the power of n minus 1. Now, here we're done. We cannot multiply 4 times 2 due to the order of operations. We have our parentheses first, then we evaluate the exponent. So we'd first need to evaluate r to the power of n minus 1, and then we will multiply it by 4. So you leave your geometric sequence alone at that point. All right, hope you all have a great weekend, and I will see you Monday.